Intro. In this lab, our group wanted to see how charged rods interact with neutral conductive objects under grounded and isolated conditions. The team tested how contact and contactless interactions affect charge transfer and redistribution, and we showed how an object can be charged without direct contact through induction. Our overall goal was to compare and contrast our predictions with experimental observations and help us understand the physical principles governing electric charge and electrostatic interactions. Materials: electrometer, acrylic rod, glass rod, PVC rod, fur, silk, wool, aluminum foil, dangling and grounded, pith ball, conductive spheres. Table 1. Set up the electrometer and use it to determine the sign of the charge of the rod after being rubbed with different cloths. For the acrylic rod, the charge was negative when rubbed with fur, negative with silk, and negative with wool.
Yeah, charging rod.
So negative? Negative. Okay. Wait, I was going to do all the fur.
This is
wool. Oh, that's wool.
For the glass rod, the charge was negative with fur, negative with silk, and positive with wool.
See fur.
Did they do anything? Yeah, just get wool.
I mean, yeah.
Okay, you're good.
Negative.
For the PVC rod, the charge was positive with fur, positive with silk, and positive with wool.
Positive for
Procedure, Part A and B, dangling foil. Part A. We charged the PVC rod with wool, then attached the dangling aluminum foil to the edge of the table. We predicted that the rod would attract the foil if we brought them together without touching. Our prediction was correct. The rod attracted the foil.
Is this for part A?
yeah.
Okay.
Touch it though. Just without touching.
Oh. It doesn't move at all. Oh, yeah. It's moving out. That's
I think
moving.
it's repelled.
It is attracting itself.
It's attracting, slightly attracting.
Part B. Again, we used the PVC rod rubbed with wool. We predicted that the rod would repel the dangling foil if we touched the rod to the foil. Our prediction was incorrect. The rod was able to attract the foil.
Oh, it's attracting, right?
Yeah.
Yeah.
Procedure Part C and D, pith ball. Part C. We charged the PVC rod with wool and we're now using the pith ball for testing. We predicted that the pith ball would be attracted to the rod without touching. Our prediction was correct. The pith ball was attracted to the rod.
Yeah.
Attraction?
Yeah.
It is attracted slightly.
Yay!
Part D. Using the same charged rod, we now had to touch the pith ball and rod together. We predicted that the pith ball would attract the rod if we touched them together. Our prediction was correct. The rod and pith ball attracted each other.
Touch. And it is attracted still.
It's just so much.
Procedure Part E. We rubbed the PVC rod with wool to create a negative charge. We placed the two spheres together, then brought the charged rod near before touching one sphere with the rod. Next, we moved the two spheres apart, then measured both of their charges. The sphere that was touched by the rod had a positive charge, while the second sphere had a negative charge.
Okay, so where I did step 1, this is step 2. And then someone just needs to pull away.
Just tell me when.
Pull it away. Without touching, and then
Negative.
so that means that that one should be positive. So it is. That means, that means that this is negatively charged, right?
Analysis, Part A. The neutral aluminum foil was attracted to the negatively charged PVC rod due to polarization. Part B. We predicted repulsion after contact, but attraction occurred. Part C. The neutral pith ball was attracted to the rod without contact. Part D. When the charged rod touched the pith ball, it was attracted to the rod. Part E. Charging by induction worked because of polarization and grounding. The negatively charged rod pushed electrons away inside the sphere, giving it a positive charge.
Good evening. Today we're reporting on an experiment investigating electrostatic interactions, how charged objects behave when brought near neural conductive objects. Joining us is our field experimenter. Can you briefly explain what you were testing?
So, certainly I can. We were studying how objects can become charged and how they interact through electrostatic forces, especially we tested charging by friction, conduction, and induction, and observed how neutral objects respond to the negative charge.
Before conducting the experiment, what did you predict would happen when a charged rod was brought near a neutral object without touching it?
So we predicted the neutral object would be attracted even though it has no net charge. Polarization causes charges inside the object to rearrange, creating an opposite charge on the sides closest to the rod.
And what actually happened during the test?
Well, our observations matched our predictions. Both the grounded aluminum foil and the isolate pith ball were attracted to the charged rod without any contact.
Okay, what happened after the rod touched the objects?
So after contact, the objects were repelled. This is because charge transferred by conduction, leaving both the rod and the objects with the same type of charge. Since the charge is repelled, the object moved away from each other.
You also performed charging by induction. Can you explain that process?
Of course I can explain that process. So yes, we brought a charged rod near a neutral conductive sphere without touching it, then grounded the sphere. This allowed excess electrons to flow away. After removing the grounded first, and then the rod, the sphere was left with a net positive charge.
So your experimental results did support your predictions overall?
Basically, the outcomes were consistent with the electrostatic theory. Minor differences could be due to environmental factors like air movement, especially in our lab.
So what was the main takeaway from this experiment?
The key to our conclusion is that the electrostatic forces depend not only on charge type, but also on whether the object was grounded, isolated, or in contact. Neutral objects can still express forces due to polarization, and objects can be charged without touching through induction.
Fascinating insights into invisible forces that shape everyday phenomena, from static electricity to lighting. Thank you for joining us.
Thank you for having me.
Conclusion. In this lab, we successfully observed charging by friction, conduction, and induction. Charging by friction occurred when we rubbed the PVC rod with wool, creating a negative charge. Charging by conduction occurred when the rod touched the pith ball, transferring charge and causing repulsion. Charging by induction allowed us to charge a sphere positively without direct contact. We learned that neutral objects are attracted to charged objects due to polarization. Grounding plays a key role in determining whether an object retains charge. The key steps to charge positively by induction are: bring a negatively charged object near, ground the object, remove the ground first, and then remove the charged object.